Hello guys, welcome back to another Cogniz education video. Today we're gonna be doing this AP Physics 1 Unit 1 FRQ. So we're told that a car moves along a straight horizontal track. The graph is a velocity over time graph and it shows the time velocity of the car as a function of time from 0 seconds to 9 seconds. So the acceleration of the cart during the interval 0 to 3 seconds. So when we look at this, we see that it's a straight line. So the acceleration is going to be constant. So we can see just by looking at this, but I'll do it. We know that the the acceleration of a velocity over time graph is just the slope. And so we can take our first point, 0, 0, and then our second point, which is 1, 2, and find the rate of change. So that's y2 minus y1 over x2 minus x1, which is 2 minus 0 over 1 minus 0, so 2 over 1, which is equal to 2 meters per second squared, because it's acceleration. So that's our answer for A. Now the displacement. One thing is that the displacement of a velocity over time graph is the area under the graph. That's because velocity is the total change in, not velocity. The displacement is the total change in position. And so calculus, since velocity is the rate of change of the position, then that means the total amount of change, that means that the integral of this would give us back the distance, and then taking the integral from 0 to 9 gives us the total change in distance, or the accumulation of change in distance over that period. And over here, we can see that this is a 3 shapes that we can easily calculate. So we have this triangle with base 3 and height 6, this rectangle with also height 6 and a base of 4, and then this triangle with the base of 2, height 6. So the area of a triangle is 1/2 base times height. That's 1.5 times 6, which is 9, and then plus 6 times 4, which is 24, I'd like to say. Yeah. And then plus half of 2 is 1, so just 6. And we get 9 plus 6. I like to do that first, so 15 plus 24. We get 39 meters. 39 meters. But there's more. Now, wants us to sketch an acceleration over time graph. But we can do that easily because, look, the acceleration is just the slope. We already know the acceleration in the first 2 seconds. It's 2 meters per second squared. So, sorry if drawing isn't that straight. So for the first 3, we have this, and then I'll do a small dotted line, because then, look, the acceleration is just the slope of this, right? Look over here, it's a flat line. So it would be 0 from t equals 3 to t equals 7. So suddenly it drops down, and it's just a straight line. And then look, now it's decreasing, it's going down. To find the slope of this, we can look at this bottom point, which is, here, let me see, 9, 0. That's going to be our second point. Our top point is going to be 7, 6. So 0 minus 6, negative 6 over 9 minus 2, which is 2, which is equal to negative 3 meters per second squared. So we're actually going down here now. That was, these were supposed to be in red. And then it's telling us that suppose after t equals 9, the car remains at rest. Calculate the average velocity. Well, since it remains at rest, that means our displacement doesn't change after 9 seconds, because this is the time we already have. Now we're adding 3 seconds to it, but during that time, we're at rest, so it's not changing. So we know that average velocity is the displacement over change in time, and we already know our displacement is 39. 12 minus 0, that's just 12. 39 divided by 12. That I'll divide both sides by 3 to make it simpler. So we get 13 over 4. That'd be 3 and 1/4, so 3.25 meters per second, because it's velocity. Okay, thank you for watching the video.